Cool. So we did some equations last time, and they were not so bad. These really aren't either. If you'll notice, the thing in parentheses, it's still just a regular x. So we're going to be able to reach back into our little bag of Algebra 2 tricks and solve most of these. All right, so this one we're going to solve by factoring out the GCF. First thing I'm going to do is move all the trig stuff over to one side. So I'm just going to minus this sine of x from both sides. And over here, we got like terms, because this is just a regular old sine of x as well. All right, now I've got 0 is equal to 2 sine of x cosine of x plus, all right, 2 sine of x minus sine of x is just 1 sine of x. Now, on the right-hand side, I can go ahead and factor this because I've got 2 sine of x's. Right? So I'm going to factor out a sine of x here. Right? All right, so if I take a sine of x away, this first term is going to be a 2 cosine of x plus, and then the second term is going to be a 1. All right. So now that it's in factored form, I can use the old zero product property. If I have this is equal to 0, if I have this times this is equal to 0, well, that means that either this is equal to 0, sine of x equals 0, or this is equal to 0. So I can take that 2 cosine x plus 1, and I can set them both equal to 0 and just solve each little equation. Okay. So for sine of x to equal 0, the only place that happens, and you can pull out that little spider web chart if you happen to have it. I don't have mine laying around. But the only place that happens is whenever x is equal to 0. So that's the only place where that happens. All right, the angle, wait, no, it's not. Shoot, what am I thinking here? Yeah, we're equal to 0. It happens at 0, but it also happens at 180 degrees. Yeah, it really helps if you have those charts. So yeah, right there at 0, that angle, and also at that angle. Those are the two spots where the y value, or the sine value, is equal to 0. All right, now if I go over to this equation, I need to move the 1 to the right side. So I've got 2 cosine x is equal to -1, and then I'm going to divide by 2. So cosine x is equal to -1/2. And then because cosine is equal to something negative, that tells me that I have to be in either quadrant 2 or quadrant 3. I'm looking for the quadrant 2 and quadrant 3 angle where cosine is equal to 1/2. All right, so I know from my little spider web chart that in quadrant 1, cosine is equal to 1/2 right here at 60 degrees. So I'm looking for the quadrant 2 and quadrant 3 angles where cosine is equal to 60, I'm looking for the quadrant 2 and quadrant 3 60-degree angles, or the reference angles that will give me 60. X equals, for quadrant 2, this is going to be 120. And then for quadrant 3, so I got 120 there, this other one is going to be 240. Sorry, I don't have that. Here, let me pause and I'll pull up that chart again. All right, so we were looking for the quadrant 2 or 3 angle, all right, because cosine is negative, that matches the 60-degree spot, because at cosine of 60, that's where your 1/2 comes into play. And so I had to pull up this chart because I had closed it out previously. So we know it's 60 degrees. So if I look over here at the reference angle in quadrant 2, that's 120. And if I look down in quadrant 3, it also happens at 240 degrees. Okay. So these are my four angles, all right, my four angles between 0 and 360, or 0 and 2 pi, that will satisfy this original equation, right? And in radian form, I guess, it's still 0, right? This one would be pi. 120, let's see here, 120, that feels like about, 2 pi over 3, but that's right. And then 240 would be 4 pi over 3. Okay. And those same rules where you do, plus or minus 2 pi n or plus or minus 360, that would still apply here if you wanted to talk about all the solutions, right? But these are only the solutions between 0